When installing an air compressor in a remote building, several wiring options exist, each with specific code implications. A key consideration revolves around whether to install a subpanel in the remote building or utilize a junction box configuration. If a subpanel is installed in the remote building, a ground rod is required. The exception outlined in the National Electrical Code, specifically Section 250.32a, typically doesn't apply in scenarios where the remote building lacks other electrical items. This is because the exception requires an equipment grounding conductor run with the supply conductors and no other grounding electrode systems at the separate building or structure. Since the remote building in this case has only the air compressor, it does not meet the requirements for the exception. The code mandates that a grounding electrode system, typically a ground rod, be installed at the separate building to ensure proper grounding and safety. This ground rod provides a path for fault current to return to the source, helping to trip the overcurrent protective device and clear the faults. In contrast, an alternative approach involves installing a metal junction box on the exterior of the remote building, incorporating a disconnect switch. This configuration allows for running the existing air conditioning circuit and the new circuit for the air compressor into the junction box. By using appropriately sized conductors and overcurrent protection, both the air conditioning unit and the air compressor can be safely powered from the existing 50-amp 240-volt circuit. However, this method relies on the grounding system of the main panel and does not necessitate a ground rod at the remote building itself. The junction box serves as a point of connection and disconnection, but the grounding is provided back to the main panel through the equipment grounding conductor. Another option involves installing a subpanel in the garage adjacent to the main panel. In this scenario, a ground rod at the remote building is not required, provided that all wiring is run from the subpanel in the garage to the remote building. The key here is that the subpanel in the garage derives its grounding from the main panel, and a dedicated equipment grounding conductor must be run with the circuit conductors to the remote building. This equipment grounding conductor provides the necessary ground fault path, eliminating the need for a separate grounding electrode system at the remote building. The choice between these options depends on various factors, including cost, ease of installation, and compliance with local electrical codes. Installing a subpanel in the remote building necessitates driving a ground rod, adding to the installation cost and complexity. Utilizing a junction box simplifies the wiring but requires careful consideration of conductor sizing and overcurrent protection. Installing a subpanel in the garage avoids the need for a ground rod at the remote building but requires running new wiring from the garage to the remote building, which could be the most expensive option. When selecting the appropriate wiring method, it's crucial to adhere to the National Electrical Code and any applicable local amendments. The code provides specific guidelines for grounding and bonding, conductor sizing, overcurrent protection, and wiring methods. These requirements are designed to ensure the safety of the installation and protect against electrical shock and fire hazards. For example, the size of the conductors must be adequate for the load they will carry, and the overcurrent protection must be sized appropriately to protect the conductors from overload. The equipment grounding conductor must also be properly sized and connected to provide a low impedance path for fault current. To elaborate on the subpanel option, consider the following details. If a subpanel is installed in a remote building, it must be properly grounded. This involves driving a ground rod, typically 8 feet in length, into the earth near the subpanel. The ground rod must be connected to the subpanel's grounding busbar using a grounding electrode conductor of the appropriate size, as determined by the National Electrical Code Table 250.66. In addition to the ground rod, a separate equipment grounding conductor must be run with the circuit conductors from the main panel to the subpanel in the remote building. This equipment grounding conductor provides a low impedance path for fault current to return to the source, helping to trip the overcurrent protective device in the event of a ground fault. The neutral conductor, also known as the grounded conductor, must be isolated from the subpanel enclosure and connected only to the neutral busbar. This separation of the neutral and ground conductors is essential for preventing objectionable current flow on the grounding system. The size of the feeder conductors supplying the subpanel must be adequate for the anticipated load, and the overcurrent protection must be sized accordingly. The subpanel must be properly labeled to indicate its function and the circuits it serves. Furthermore, all wiring must be installed in accordance with the National Electrical Code and any applicable local amendments. Now let's delve deeper into the junction box option. Installing a metal junction box on the exterior of the remote building provides a convenient point for connecting the existing air conditioning circuit and the new circuit for the air compressor. The junction box must be sized appropriately to accommodate the conductors and connections, and it must be weatherproof to protect against the elements. A disconnect switch should be installed adjacent to the junction box to provide a means of disconnecting power to the air compressor for maintenance or repairs. The disconnect switch must be rated for the voltage and current of the circuit, and it must be readily accessible. The conductors from the existing air conditioning circuit and the new circuit for the air compressor must be properly spliced and insulated within the junction box. The splices must be made using approved connectors, and the insulation must be rated for the voltage of the circuit. The equipment grounding conductors from both circuits must be connected together within the junction box and bonded to the metal enclosure. This bonding ensures that the metal enclosure is at ground potential, reducing the risk of electric shock. The conductors must be routed and secured within the junction box to prevent strain on the connections. The junction box must be properly labeled to indicate its function and the circuits it serves. Again, all wiring must be installed in accordance with the National Electrical Code and any applicable local amendments. Finally, let's examine the option of installing a subpanel in the garage. If a subpanel is installed in the garage, it can be fed from the main panel, provided that there is sufficient capacity in the main panel. The feeder conductor supplying the subpanel must be sized appropriately for the anticipated load, and the overcurrent protection must be sized accordingly. The subpanel must be properly grounded to the main panel's grounding system. This grounding is typically achieved by running a separate equipment grounding conductor with the circuit conductors from the main panel to the subpanel. The neutral conductor must be isolated from the subpanel enclosure and connected only to the neutral busbar. From the subpanel in the garage, individual circuits can be run to the air conditioning unit and the air compressor in the remote building. These circuits must be sized appropriately for the loads they will serve, and they must be protected by overcurrent devices in the subpanel. The equipment grounding conductors from these circuits must be connected to the subpanel's grounding busbar. No ground rod is required at the remote building if the subpanel in the garage is properly grounded to the main panel and a separate equipment grounding conductor is run with the circuit conductors to the remote building. All wiring must be installed in accordance with the National Electrical Code and any applicable local amendments. In summary, when wiring an air compressor in a remote building, you have several options to consider. Firstly, installing a subpanel in the remote building and driving a ground rod is a common approach, but adds to the installation cost and complexity. Secondly, utilizing a junction box on the exterior of the remote building simplifies the wiring but requires careful consideration of conductor sizing and overcurrent protection. Thirdly, installing a subpanel in the garage avoids the need for a ground rod at the remote building but requires running new wiring from the garage to the remote building. Choosing the best option depends on your specific circumstances and the applicable electrical codes. Always consult with a qualified electrician to ensure that your installation is safe and code compliant. Remember, safety is paramount when working with electricity. Always to energize circuits before working on them and use appropriate personal protective equipment such as insulated gloves and safety glasses. If you are not comfortable working with electricity, hire a qualified electrician to do the work for you. The National Electrical Code is a comprehensive set of standards for electrical installations, and it is essential to be familiar with its requirements. The code is updated every 3 years, so it is important to use the latest edition. Local electrical codes may also apply, so it is important to check with your local authorities. When selecting electrical equipment, such as conductors, overcurrent devices, and wiring devices, be sure to choose products that are listed by recognized testing laboratory, such as Underwriters Laboratories, Intertech, or CSA Group. Listed products have been tested to meet safety standards and are suitable for their intended use. Always follow the manufacturer's instructions when installing electrical equipment. Improper installation can lead to electrical hazards and equipment failure. Regularly inspect your electrical system for signs of damage or wear. Look for cracked or frayed wires, loose connections, and damaged equipment. If you find any problems, have them repaired by a qualified electrician. Never attempt to repair electrical equipment yourself unless you are qualified to do so. Electricity can be dangerous, and it is important to take precautions to protect yourself and your property. In addition to the technical aspects of wiring an air compressor in a remote building, there are also some practical considerations to keep in mind. Firstly, consider the location of the air compressor. It should be located in a dry, well-ventilated area where it will not be exposed to the elements. Secondly, consider the noise level of the air compressor. Some air compressors can be quite noisy, so you may want to locate it in an area where the noise will not be a nuisance. Thirdly, consider the power requirements of the air compressor. Make sure that the circuit you are using to power the air compressor is adequate for its power requirements. Fourthly, consider the future needs of the remote building. If you anticipate adding more electrical equipment to the remote building in the future, you may want to install a larger subpanel or run additional circuits to the building. By considering these practical considerations, you can ensure that your air compressor installation is safe, reliable, and meets your needs. Remember that this information is for general guidance only, and it is not a substitute for professional advice. Always consult with a qualified electrician before undertaking any electrical work. Staying informed about electrical safety and best practices is crucial for homeowners and professionals alike. The National Electrical Code serves as the cornerstone of safe electrical installations, providing detailed guidelines for wiring methods, grounding, overcurrent protection, and equipment selection. Adhering to these standards minimizes the risk of electrical shock, fire hazards, and equipment damage. Regularly reviewing and updating your knowledge of the NEC is essential, as it undergoes revisions every 3 years to incorporate new technologies and address emerging safety concerns. Furthermore, understanding the specific requirements of your local electrical codes is equally important, as these may supplement or modify the NEC to address unique regional conditions. When working with electricity, always prioritize safety. De-energize circuits before commencing any work, and utilize appropriate personal protective equipment such as insulated gloves, safety glasses, and arc flash protection. If you lack the necessary expertise or confidence, enlist the services of a qualified electrician to ensure that the work is performed safely and correctly. Regular inspections of your electrical system can help identify potential hazards before they escalate into serious problems. Look for signs of damage such as cracked or frayed wires, loose connections, and corroded components. Pay close attention to areas where wires enter or exit enclosures, as these are common points of stress and wear. If you detect any issues, promptly address them by contacting a qualified electrician. Preventative maintenance can extend the lifespan of your electrical system and reduce the likelihood of costly repairs. Keep electrical panels and equipment clean and free of dust and debris, which can impede ventilation and cause overheating. Periodically test ground fault circuit interrupters, or GFCIs, to ensure that they are functioning properly. GFCIs are designed to protect against electrical shock by quickly interrupting the circuit when a ground fault is detected. Consider investing in surge protection devices to safeguard your sensitive electronics from voltage spikes. Surge protectors can help prevent damage to computers, televisions, and other valuable equipment caused by lightning strikes or power surges. Be mindful of the electrical load on your circuits. Avoid overloading circuits by plugging too many devices into a single outlet or extension cord. Overloaded circuits can overheat and cause a fire. Educate yourself and your family about electrical safety. Teach children not to play with electrical outlets or appliances, and emphasize the importance of staying away from down power lines. By taking these proactive steps, you can create a safer electrical environment for yourself and your loved ones. Remember that electrical safety is an ongoing commitment, requiring diligence, awareness, and a willingness to seek professional assistance when needed. By staying informed, practicing safe work habits, and maintaining your electrical system, you can minimize the risks associated with electricity and enjoy the benefits of a safe and reliable power supply.